Hello everyone, welcome back to my channel. I'm sorry for the previous video, I didn't complete it well and it just cut off and it by mistakenly cut off. So let me continue. A flame is the signing zone in which a combustible gaseous material undergoes combustion, producing heat and light. All substances do not give a flame while burning. Substances which vaporize while burning give flame, and those which do not vaporize while burning do not give flame. For example, coal does not vaporize and so does not produce a flame, luminous and non-luminous flame. A blue color flame which produces a little light is called non-luminous flame. A non-luminous flame is obtained when the fuel is burnt completely. A fuel undergoes complete combustion only when the supply of air or oxygen is sufficient. Thus, when a fuel burns in the presence of sufficient air, a non-luminous flame is produced. LPG burns with a non-luminous flame. Kerosene burns with a non-luminous flame in a pressure stove. A yellow flame which produces heat and appreciable amount of light is called a luminous flame. A luminous flame is obtained when a fuel undergoes partial or incomplete combustion. It happens only when the supply of air or oxygen is insufficient. When a fuel burns in the presence of limited insufficient air, a luminous flame is produced. When a candle is lighted, the wax melts. This method wax this method wax rises up through the wick due to the capillary action and gets vaporized. The vapor of wax then burns in the air to produce a luminous flame. The candle flame is yellow and luminous due to incomplete combustion of wax vapor. Structure of a flame. A flame consists of four zones. These are outermost non-luminous blue zone of complete combustion, central or middle luminous zone of incomplete combustion, inner dark zone of no combustion, lowest blue zone. These zones are described below. Outermost non-luminous blue zone of complete combustion. This zone is faintly visible and surrounds with the yellow luminous part of the flame, and the zone the wax vapor undergo complete combustion because the plenty of air is present around it. This zone is the hottest part of the candle. You might have seen goldsmiths blowing the flame of lamp for melting the gold and silver. They blow the outermost part of the flame because it is the hottest part. Central or middle luminous zone of incomplete combustion. The central luminous zone of the candle is bright yellow and luminous. In this zone, wax vapor undergoes incomplete convention incomplete convention because not enough of air is present here. The incomplete convention of wax vapor produces carbon particles. These unburned carbon particles get heated up and start glowing. These glowing carbon particles make the flame luminous. Thus, the central zone of the candle flame is luminous due to the incomplete combustion of wax vapor in this zone. This part of the flame has moderate temperature. Inner dark zone of no combustion. The dark zone around the wick is called inner dark zone of no combustion. In this zone, very little or no combustion take place because in this zone no air is present. This zone is dark black due to the presence of unburnt carbon particles in the wax vapor. This part of the flame is the least hot. The lowest blue zone. This zone is located at the base of the flame. The blue color of this zone is due to the burning of carbon monoxide produced in the dark zone. Fuels. A combustible substance which on burning produces a large amount of heat and light is called a fuel. Some commonly used fuel are wood, coal, liquefied petroleum gas (LPG), petrol, diesel, and kerosene. Classification of fuels. Fuels are classified on the basis of physical states in which they occur. So, fuels are classified as solids, liquids, and gaseous fuels. Solid fuels, combustible substances which are solid at room temperature are called solid fuels. Solid fuels contain mainly carbon, both as free and combined carbon in rural areas, firewood, agricultural waste, animal dung, uh, cakes, and the major source of energy. Examples: some solid fuels are coal, coke, wood, charcoal, animal dung cakes, agricultural waste. Liquid fuels. Volatile liquids which produce combustible vapors are called liquid fuels. Kerosene is the most commonly used liquid fuel. Examples: some common liquid fuels are petrol, diesel, kerosene, alcohol. Gaseous fuels. Combustible gases or mixtures of combustible gases are called gaseous fuels. Examples: some commonly used gaseous fuels are natural gas, biogas or gobar gas, coal gas, water gas, producer gas, hydrogen gas, liquefied petroleum gas (LPG), compressed natural gas (CNG). Petroleum gas is obtained by produced during the fractional distillation of petroleum. Categorize characteristics of an ideal fuel. An ideal fuel should have the following characteristics. It should be very cheap and easily available. It should burn at a moderate rate. It should not produce any poisonous and irritating flames during burning. It should leave no residue ash after burning. It should produce large amount of heat per unit mass. That is, it should have high calorific value. It should be safe and convenient from the storage and transportation point of views. Its ignition temperature should be above room temperature so that it is safe to use such a fuel. Substances which can have above characteristics are said to be ideal fuel, but practically an ideal fuel is not available. A good fuel has most of the characteristics mentioned above. Fuel efficiency. Fuel efficiency. Efficiency of a fuel is measured in terms of its calorific value, the amount of heat produced when 1 kilogram of fuel is completely burnt in air or oxygen is called its calorific value. The calorific value expressed by the kilojoule per kilogram, denoted as kj by kg or kg to the power minus 1. Calorific value of some typical fuels are given below. Calorific values of some common fuels. Fuel: cow tongue cake, calorific value 6,000 to 8,000. Wood: 17,000 to 22,000. Coal: 25,000 to 33,000. Petrol: 45,000. Kerosene: 45,000. Diesel: 45,000. Methane: 50,000. CNG: 50,000. LPG: 50,000, 55,000. Biogas: 35,000 to 40,000. Hydrogen: 15 150,000. From the above table, it is clear that LPG is more efficient than wood because it produces more heat, 55,000 kJ, on burning completely than same amount of wood, 17,200 kg or kilojoule is the kilojoule, or coal fuel 25,000 kilojoule is burnt. Also, hydrogen is more efficient. Bringing of fuel leads to harmful products. Fuels such as wood, coal, petrol, diesel, kerosene contains carbon. Bringing these fuels produces gases like carbon monoxide, carbon dioxide, oxides of nitrogen, and oxides of sulfur. In addition to these gases, generally in the most of solid fuels, smoke is produced. These gases produce the unburned carbon particles cause air pollution. The solid fuels such as wood, coal, after burning also leave behind ash. This ash is, if not disposed of properly, may cause air and water pollution. Pollutants in the air may cause in the animal disease, or air cause many disease than reactions in human beings. An increase in the concentration of carbon dioxide is in the atmospheric leads to increase in the average temperature on the earth. This leads to global warming. Global warming causes changes in the pattern of crop cultivation, adversely affected in the monsoon rains, causes excessive melting of polar ice, thereby rising the level of water in seas and oceans. This would cause flooding and submerging of many low-lying areas. Carbon monoxide is one of the most dangerous air pollutants. Carbon monoxide, when inhaled, combines with hemoglobin in the blood. Thus, blood cannot blood cannot carry oxygen. This causes a deficiency of oxygen in the tissue, resulting into suffocation and even death. It is due to the reason that it is not advisable to sleep in a closed room with coal-fired fireplace, anxiety inside on a cold winter night. The oxides of sulfur and nitrogen cause respiratory problems and produce acid rains. The rainwater containing dissolved oxides of nitrogen and sulfur is called acid rain. The acid rain is very harmful to all living and non-living things. Some harmful effects of acid rains are given below. Acid rain is highly acidic and corrosive Corrosive acid rain leads to corrosion of metallic structures. Acid rains reacts with limestone and the marble of the historical monuments. Due to such reaction, marble gets corroded and loses its shine. Acid rain also affects plant and aquatic marine life, that is, it destroys plant, fish, etc. Acid rain leads to loss of soil fertility. Nowadays, petrol and diesel are being replaced by CNG, compressed natural gas. It is considered as a cleaner fuel as on burning it does not produce harmful substances. Also, wood, which has been used as domestic as well as industrial fuel for centuries, is now being replaced by LPG. This is because LPG has much bigger, much higher calorific value than wood. Also, it does not produce smoke and does not leave behind ash on burning. So that is for today, and thanks for watching the video. Please subscribe my channel if you are new in here. Please like it and comment down if it was helpful or not, and please practice reading, and you can read more. And hope you have gained a lot of knowledge from this video. Share this video who is needed and comment down. So subscribe my video and also press the bell icon, and also the all one, so that you can get my notification fast, and when I will post my video, then you can immediately get the notification. So that's for today, and thanks for watching my video.